Hello viewers, welcome to Michael Blair Virtual School. I am Michael Blair Tasian, a 15-year-old student pursuing bachelor degree in mathematics and ICT. I had the privilege to complete junior high school education at age 9 and thereafter represented the Fafara Community Day Senior High School at the National Science and Maths Quiz Competition at age 11. My background, experience, and competencies give me the privilege to teach you mathematics the way you love it and excel in your mathematics examinations. Come on board, let's learn together. Welcome to another section of mathematics from the Basic 7 Common Core Program curriculum. We will be dealing with B7.1.2.1.2. That is ability to demonstrate and determine commutative property of addition and multiplication. If you've ever thought mathematics is difficult, then I'll prove to you in this section why it is not supposed to be so. So, come on board and let's enjoy this lesson together. First of all, by the end of the lesson, you the learner should be able to 1. Identify and explain what commutative property is. 2. Prove the commutative property for the 4 basic operators in mathematics, which are addition, subtraction, multiplication, and division. So let's start our lesson for today. You heard me say commutative quite a number of times, and I want you to know what commutative means. Commutative, however, cannot be done for numbers or alphabet, but can be done for what we call operation signs. Operation signs. An operation guards how you add, subtract, divide, and multiply numbers by themselves. So, however, an operation is said to be commutative when you change the position of the items involved in that operation and you still get the same answer. And we are going to be trying it for addition, multiplication, division, and subtraction. So let's test the commutative property on addition. So in addition, you should keep it in mind that anytime you are adding things together, so let's say 2 plus 3. Now, in this instance, addition is said to be commutative if when I interchange the positions of the 3 and the 2, I'm still going to get the same answer. So that is to say that whether I do 2 plus 3 or 3 plus 2, if I get the same answer, which is 5, then that means addition is commutative. That is what commutative property is about. It seeks to tell you that anytime an operation is being used and we interchange the positions of the items involved in the operation, if we get the same answer, then that means that operation is commutative. So we've just proven how addition is commutative. So we can try it with another example like 7 plus 2 being equal to 2 plus 7. And let's check if it's true. 7 plus 2 is 9. 2 plus 7 is also 9. And by so doing, we have finally come to the conclusion that addition is commutative. Subtraction is what we have to check next. So in subtraction, let's take two things to subtract, like 7 minus 2. 7 minus 2 gives us 5. Let's interchange and rather make it 2 minus 7. And we get negative 5. 5 and negative 5 are not the same. Therefore, subtraction is not commutative. What if we tried for another set, that is 5 minus 2, giving us 3, and 2 minus 5, giving us negative 3. 3 and negative 3 are not the same, and therefore subtraction is not commutative. Multiplication is what we want to check next. So in multiplication we operate, that is 7 times 2, what do you get? 14. 2 times 7, and what are we getting? We also get 14. And therefore, that should tell us that our answers were the same, and therefore multiplication is commutative. Because when you're operating in multiplication and you change the position of the numbers involved in the multiplication, you still get the same answer. It will also be nice if we try working out with this example. 3 times 4 giving us 12, and 4 times 3 giving us 12. So we have 12, 12 after interchanging the positions, and therefore we can say that multiplication is also commutative. Finally, let's check for division. 3 items divided by only one person. See that one person takes all the 3 items for. But if I'm to divide one item by 3 people, we are going to get 0.333333, and 3 is not equal to 0.3333. Therefore, division is not commutative. If we can change the positions. If it was commutative, it should have given us the same result, but it gave us different results for interchange positions, and therefore we cannot conclude that division is commutative. Try and operate the following, that is 2 divided by 5. Give me the answer. 5 divided by 2. Give me the answer. And based on your answers, tell me whether division is commutative and explain why. And that will be your assignment. Make sure you send your answers to michaelblesschool@gmail.com. It's been Michael Blair Tasiame having you on the Michael Blair Virtual School. Don't forget to subscribe to our channel, like our video, comment on it, share it, so that we can continue to help you academically on the Michael Blair Virtual School. Thank you.